Okay, apologies for the smudges. I kind of messed this up a couple of times, just carelessly. Composite. The composite of f and g, the composite that's denoted f circle g, is the function which, when evaluated at x, has the value you get if you evaluate g at that value of x, and then f at that value of g. So, for example, if f of x is the square root of x minus 4, g of x is 1 over x squared, then what's f of g of x? F circle g of x is the function which, when evaluated at x, gives you f of g of x. So what's f of g of x? Well, f of x is the square root of x minus 4. Excuse me, so f of g of x has been replaced by g of x, so we better replace this x by g of x. We're going to get the square root of g of x minus 4. And, of course, then, since g of x is 1 over x squared, this is the square root of 1 over x squared minus 4. Now, we ask about the domain of this function. Okay, what's the domain? Well, there are two things, one of which I haven't written down here, but we talked about. First of all, x can't be negative, because then x squared would be 0, and you'd be dividing 1 by 0. Not only is division by 0 undefined, which is something you're supposed to have learned many times over, but it's undefined for a reason. It's because you can't count to 1 by zeros. Okay? And that's really the meaning of division. Of course, it gets expanded a little bit, but if you can't count to this number by zeros, or at least count to this number by ones, you can't do the division, and you can't. So it's undefined. So x can't be 0. We want to remember that because I didn't write it down. So we're going to get it over here. Okay, so the other restriction on x is that this denominator here can't be, or I mean this expression inside the radical can't be negative. If it's negative, then its square root is an imaginary number, and we're only interested in functions in this course whose values are real numbers. So if you have a negative here, x isn't in the domain. X is not legal for substitution into that function. So we can write the fact that this can't be negative as 1 over x squared minus 4, same expression, has to be greater than or equal to 0. And then we solve this equation. It's very simple. We put the 4 over on this side, add 4 to both sides to do it non-superstitiously, multiply both sides by x squared, divide both sides by 4, and then we've got to be a little careful. X squared less than or equal to 4 means x is less than or equal to the square root of 1/4, and also that it's greater than or equal to the negative square root of 1/4. And the square root of 1/4 is 1/2, so we conclude that negative 1/2 has to be less than or equal to x, which is just turning this around, and x has to be less than or equal to 1/2, so we have a combined inequality here. So x can't be 0, and x has to be greater than or equal to negative 1/2 and less than or equal to 1/2. Now, of course, if x squared is equal to 1/2, then 1 over x squared, well, actually, yeah, okay, 1/2 is legal. Not sure what I was about to say. And the domain, a little careless when I wrote this down. The domain is therefore, it includes negative 1/2. Does it include all numbers up to 1/2? Well, no, because it can't include 0. So the domain is negative 1/2, 0, not including 0, union 0, 1/2, and including the 1/2. We also can talk about the range of the function. As x approaches 0, the 1 over x squared gets bigger and bigger with no limit. So what's under the radical? I mean, if you subtract 4 from something really big, you're still going to get something really big. And if this approaches infinity as x approaches 0, then the square root is also going to get as big as you like. Okay? So the square root can get as big as you like by letting x be closer and closer to 0. Okay? Now, if x is equal to 1/2 or negative 1/2, then it's very easy to check out that this is equal to 0. So you suspect that any number from 0 to infinity, in other words, any number greater than or equal to 0 would be in the range. So without writing down the details of that argument, the range is 0, and 0 is possible. Let x equal 1/2 or negative 1/2. Infinity.